Good morning, everyone. So I thought to register a second lecture or a second Ansys example, again, to show you how to use the workbench. And again, we are doing structural analysis. So if you double click on structural analysis, or simply you can just take it and move it into this workspace here after you start Ansys, of course. And then you can go, of course, you can name it. So what I'm trying to do today, and I didn't do it before, so I'll intentionally do some errors and fix it just to show you more capabilities of the software. But what I'm trying to do here is to solve the example problem of the tapered part that we had in class. So again, as I told you before, you can always go and change the default material is structural steel. But if you go to the engineering data source and basically go to general materials here, you'll find a lot of material and you can define your own material. So I'm just going for sake of, you can add as many material and then use whatever you want to use, or you can use a composition of material. So I'm going to add aluminum and stainless steel. Okay, and then we just go here, so you can see here that this is the check mark. This means good. Now we go to the geometry and generate the geometry, and you have three options. One option is to import from an external source, SolidWorks or whatever. The second is to use the latest space claim geometry modeler, which is more advanced, more user-friendly. It basically gives functions like based, copy, so on and so forth. Or you can use the older one, which is the design modeler, which is, according to reviews, is very good for simple geometries, which what we are doing, right? But both of them are pretty much the same. I think if you use one, you wouldn't struggle much to use the other one. But I'm going to again use the design modeler. And during the presentations, we might shift between them, but for now, I'm sticking to the design modeler. So it will open the design modeler, and as you can see, it's a graphical software. And if you go here to I think what you can do, you can fix this here. So I'm just going to create something on the XY plane or the ZY plane. You can basically click here. So this will give you the XY plane. So I think what I want to do is to create the tapered shape that we used before. So in that case, what I'm going to try, I'm trying to do, so assuming the Y is this direction, so I'm going to plot in the XZ plane. So let's do that. Let's see if it's going to work or not. And what I need to do is to go to sketch, and what I'm going to sketch is, do you have a trapezoid here? No, we don't have a trapezoid, so we are going actually, let me try to do something. So you can do lines, right? So for example, you can click here, it's not drawing. Okay, so I'm going to change this. I'm just going to go to the XY plane, and let me see, I just want to know why. If I go here, XY plane, and I click on a sketch 1. So let's see if it's going to allow me to draw or not. Okay, sketch, lines. Okay. Let's see what this generated. Oh, line, yeah, okay. So yeah, so what I want to do, I want to delete this. I'll just show you. I'm just exploring. Actually, I didn't prepare this beforehand, so I can show you some of the things that we can do. Modeling. So you can go simply here and delete this. Okay. So let me go here, Z plane, and then just going to go here, and you can directly draw, or you can add, new sketch. So I'll find it sketch 2. Okay, sketch, and I'm going to use lines, because you cannot create a trapezoidal, right? So I'm just going to click here, click here. Hopefully it will look good. You can see here horizontal, making the constraints. You snap here, and you snap here, right? So let me try to zoom here and see. Oh, that's not good, right? Okay, so you can see here it's not closed. It has to be closed volume to be to extrude it. So I'm just going to go again. Easy thing to delete. Okay, let me figure something else. So if you go here, you don't need to. If it's only one sketch, you don't need to do it, right? You can do it right away. So sketching line. Line, then line again, and what you can do is one of these options that I saw, just show it there. Oh, so this is selection filter. You can click on this selection filter to pick a point, and then I'm going to book this point, and then I'm drawing a line. Of course, I mean, you can enter the dimension, and then I'm going to pick line again, and I'm going to pick this point and move horizontally. Okay, horizontal, and then pick another point here, pick another point here. So let's see how things looks like. So let's do dimensioning, right, in general. So let's do this here, let's do this here, okay, let's do this here, let's do this here, let's see how this works. Then you can see the dimensions here. I want to change the units to millimeters, so I'm not going to go into, so H1, which is this one, is H1 and H2, so 7,000. Okay, so let's make this 400, and let's make this one 300. Oh, L1 is 400 and 400. Let's see what's happening. Okay, so basically zoom to fit. So yeah, you can see it is kind of what we're hoping for. Maybe we can change the lower one to 200, make it more like this one, and then maybe make this 300. Yeah, more like the example that we had, right? Hopefully this is work. Of course, one of the things that you know in solid modeling, I guess you guys might know, is that if you want to extrude or do solid modeling, that thing need to be closed, and the same thing for finite element. So let's see if this is closed or not. So we select this geometry, or you select it outer, and we go to extrude, and of course extrude, apply. This means you're going to create sketch 3, and then we are going to normal and let's make it 50 and see what's going to happen. Okay, and I'm going to click here, and this is thickness, just calling this as a parameter. We might be able to use it for some optimization later on, or we can do this later on. So once this is done, you select all this information. What you can do is basically generate. Okay, so if I go to the ISO, you can see here that this is pretty much what I have, right? So this is the object that we had. You can, of course, if you want to make it a little bit thicker, you can, let's make it make it 70 if you want to, or you can make it 60. So you remove this, make it 70. If you make it a parameter, this means that you know, okay, and then you can go and generate again. You can feel it's thicker, right? So okay, so let's, of course there is an option to get rid of the dimensions. I'm not sure the dimensions, I'm not sure how, but we have generated a solid here out of a sketch 3. So this is basically, if you remember, this is my object that we have, and then we need to apply the load. So it was fixed from the top, and it was the load was applied down here, right? Remember, we had calculated the reaction force in the example. So let's go. I think, okay, of course, one of the options here is for you to get rid of the dimensions. You can display vertices, which are the points that define this if you want. This will be each direction. Again, you can play with these things. One of the options is not to show the dimensions, but I am not able to see it now, so we'll leave it. So we're done with this now. What we need to go is to go back to Ansys workbench, and you find the geometry is done. So double click to go to the model, and the model is basically starting the conversion to finite element. So you see here starting mechanical. So it's loading. So this is my workpiece. Of course, you can click on the scroll model and you can rotate and all the stuff. As you can see, we should have done this in a better way, but anyway, this is the geometry. Of course, you can always edit and do things. So, I mean, in terms of creating the geometry, but again, I think the purpose here is to just get you familiar with Ansys. So let's go material geometry. If I go to the geometry here, solid, so you have the option here to select the material. So you can stay structure, steel, you can select any of the material you can use. So I'm going to use aluminum. Aluminum is an easy material that basically you can make it a parameter, so you can change the material for optimization if you want to do that later on. Then go to static structure, insert, and again here what you are looking for, fixed support. So fixed support, what I need to do is the display, no, not here. Go to home and you select this face, right? So geometry selection, one face, and fixed support. So no, not this one, sorry. Okay, so what you can do always when you mistake, you can always delete, right? Delete. Okay, now we go here, we insert fixed support and geometry selection, this one, and then you apply. So this you can see as a fixed support. Then I want to actually look in here. No, that doesn't look good. So I better rotate it so I don't get confused. And okay. right? You keep rotating things. I think if you hold this this thing as well here, the ISO, you can rotate it, anyway. Or you can just rotate it with this one here, so to make it easy. Okay, so I want to apply a force to this face here, so I go static, insert, and then you apply a force. And where do you want to apply the force? No, not two faces. That's not cancel. Okay, no, we're not doing that. We don't want to go to this kind of selection. So I go home, and no, you don't want that. This force is not right. So delete. Of course, there's a way to edit, but just I think sometimes it's easier to delete than to edit things. So force. So what you can do, there is an option here, select mode, and what you want to select, yeah, this option. So either you select an edge, a face, or a point. So I'm going to apply the force to an edge. Just going to select this edge, right? And again, as you do the forces, so apply, and you can, go to a vector, you can apply a component. So in my case, the component is in the y direction. It's in the negative y direction, so I might make it minus 10,000. Okay, so I go back to my ISO, I go back to this one, so the force is applied here. And of course, you could have selected a point in the middle. You can apply different forces. You can apply pressure. You do whatever you want, right? So this is basically completes the setting. So what we need to do now is we need to create the mesh. Of course, one option, you can generate the mesh first and apply these, or you can directly generate the mesh after. One of the options of generating the mesh before is you can apply the load to an element or to a node, which is a point. So this is one of the features. So if you click on mesh, you'll find all the information here. Basically, you can select, either enter the information manually or select between a coarse mesh, a medium, and a fine mesh. Let me go to a fine mesh, right? And then just go and generate mesh. Remember, we solved this using 3 elements, using 4 elements. So you can see here how many elements are there, right? I mean, the information is provided here, the number of elements, and statistics. If you go to statistics, you should find nodes and elements, 480 elements, right? As compared to the 4 elements that we solved before. So I want you, once you solve this and see the results, maybe you can edit the file or create the file with the same material properties in the example, and see how the element size affects the element number of elements affect the quality. So if we go to the solution, and this is basically what you need to see. I need to see deformation. I need to see directional deformation. I need to see stresses. I want to see normal stresses. I want to see shear stresses. I want to see, this is a very good, which is the stress tool, maximum tensile strength. Okay, so you add whatever you want to see. You can always add an update. So once this is done, let's solve. We'll see now if there is a problem or not. So things seems to be moving okay. We will look for messages here, you look for warnings, or for errors. Errors are the issues, warnings are not a problem. Okay. So this is the solution information. So this is the total deformation. So again, cantilever, you can see here the deformation. You can see the directional deformation in different directions. You can see normal stress, stress concentration areas. You can see shear stress. You know what is shear stress. You can see the tool here gives you the safety factor. Safety factor is basically the safety factor, the maximum load it can handle with the material properties. So in that case, you can see here if you click on safety factor, I think minimum is greater than 10, minimum occurs in solid, so you can get more information. So this is basically an example of another example of finite element, and this is basically related to the what you guys have solved in class manually, or what we solved in class. So you can always create this and basically experiment with the parameters and see how it works and how the deflection and everything and how the number of elements affects the solution. Okay, so I hope you find this useful, and I'm going to stop short here, and then another video will follow. Thank you. So if we go back to the project here, you're going to find that you have the check mark for all of the points, and then you will see here a parameter set, which is basically all the parameters that or the dimensions that we have converted into parameters in our design.